In the last couple of videos, what we have seen was the details about the layer, the details about TCP IP layer, the details about OSI layer, right? What are the layers? What are the functions of the layers and stuff like that. Now, let's take one example here wherein a client is trying to access a server and then see at each layer what are the things that are actually happening. So let's take a very simple example. A PC is connected to a router, and that router has two interfaces. One is interface 1 int1 and interface 2 int2. Interface 1 which is connected to the PC, interface 2 that is actually connected to the next router's interface 1, and finally router 2's interface 2 is connected to the web server. And what the PC is trying to do is it is trying to access the web server. It is accessing the web server, and then it is trying to access some content in the web server. So as that happens, let's see what happens at each layer, starting from the PC, and then as the packet moves to the router 1, to the router 2, and to the web server. Let us see at each layer what are the things that are actually happening. So let's start with the PC. So at the PC, as you know, when you wanted to access any of the web application, you'll be opening your browser, and that browser is an application which is trying to access the web server, and usually the protocol that will be used is HTTP or HTTPS. So what happens at the TCP IP model, TCP IP layer, is the application will be triggering to use the protocol HTTP or HTTPS. In this case, I have taken the example of HTTP. So the browser opens, the moment browser opens, that is the application. Browser is the application, which is a client application using the protocol HTTP at the application layer. Okay, now the user types in the URL or the IP address of the web server and then tries to access the server. Then let's see what happens next. What happens next is at the application layer. I remember the rule of thumb in the previous video, all the applications and services in one layer, it will be able to access or request services in the same layer or in the bottom layer. So in this case, what happens is HTTP is going to call the transport layer, and it calls the port 80. So HTTP is actually using the transport layer protocol TCP, and it uses port 80, which is the destination port. So, and again, we will go over the details of how a TCP, a TCP header looks like. But remember, there are two major important parts of that TCP header. One is the source port and another is the destination port. Source port will be the port that is actually originating from the PC, and that will be some random port which is above 1024. Again, we will go deeper into that when we talk only about TCP, because we need to know, if you really want to be want to master the networking concept, then you need to know in depth of the TCP headers and stuff like that. So we'll have a separate video on that, and we will dive deeper. But right now, remember that the TCP will be having source port and the destination port, and the source port will be a random port, and the destination port is going to be port 80. And how does it know it has to use port 80? Because it is triggered by HTTP, and it is coded, or it is programmed to use the protocol TCP and having the destination port as 80. Now let's see what happens. Now again, one more thing, very importantly, what happens is we are encapsulating the HTTP request into the TCP header, right? So the encapsulation of TCP in HTTP in TCP happens at this stage. Now let's see what happens at the network layer. So remember the topology, we are having two routers and the PC trying to access the server. Now the network layer, it is responsible for understanding how I can reach the end destination, and in this case the end destination is going to be that server. Now the PC will know using the routing methods, and there are some other concepts as well, but as of now let's put that concept under the bucket called routing as such, right? So the PC now knows that it has to send, for it to reach the server, it has to send the packet to the router 1. So now at the network layer, which is dealing with the IP addresses and routing, what happens is the TCP and the HTTP, it will get encapsulated into the IP header. And again, we will go deeper into IP header, because unless you know TCP, UDP, and IP, and also some of the applications, you can never say that you are you have mastered the basic concept of the networking. We'll go over that. But remember, for now, for this particular video, remember that for the IP address, there are two major fields. One is the source IP address and another is a destination IP address. So what would be the source IP address? Obviously, the source IP address is going to be the PC's IP address. And obviously, the destination IP address is going to be the server's IP address, because that is where the communication between communication has to happen between the PCs and the servers. Now, all the routers in between are only enabling these PCs and the servers to communicate to each other and send the IP packets. Once again, what happens is we are doing an encapsulation. We are encapsulating at the network layer. The TCP, which is having the HTTP, is getting encapsulated into the IP. Now, that's the part of the network layer. Now, let's see what is the responsibility of data link layer. Data link layer responsibility is to send the packet in that particular segment. So let's understand that. So in this case, the segment is going to be the link between the PCs and the router one. Again, what happens is, assuming Ethernet is a technology that is used in the data link layer, we again encapsulate the entire IP, TCP, and HTTP, basically the IP which is having TCP and HTTP. We encapsulate that into the Ethernet header. And at the Ethernet, like at the transport, we use the port number. At the network, we use the IP address. At the data link layer, we use the MAC address. So here again, there are multiple fields for the Ethernet header, but one of the most important is the source MAC address and destination MAC address. Now, it is very, very important to give a second to understand here. The source MAC address is going to be the PC's interface MAC address, and the destination MAC address is going to be the router 1's interface 1 MAC address, because the data link layer is only responsible for sending the packet in that particular segment or the link. And once it reaches the router, it is router's responsibility, or it is network layer's responsibility to send it back. So only thing that this data link layer is concerned about is somehow get me the MAC address of this particular router, and there is a method through which we get the MAC address. Again, we will go deeper into that. There is a protocol called ARP and reverse ARP and stuff like that, which we need to go deeper and deeper for you to be a master in network. Now, what happens after that? Remember, again, we are actually doing the encapsulation. Once that happens, at the physical layer, it is all signals, ones and zeros. So all the ones and zeros are sent into the data link layer, and the data is sent to the router 1. Now, finally, the data that actually goes onto the wire is going to be these ones and zeros, which is having the data link layer encapsulation, and it has, of course, the IP encapsulated in that, and inside that IP it is having the TCP, and inside the TCP it is having the HTTP request or data, whatever, right? So this is how the packet is actually going from the PC to router 1. Now, again, everything of these things at the physical layer is also encapsulated. Now, once that happens, now let's see what happens when the packet reaches the router. Do remember that router is a device that is actually acting in the network layer. What happens once the packet reaches the router 1 is it needs to identify where this packet has to be sent, because remember, the responsibility of the device called router is to send the packet from the source to the destination, right? Now, what router 1 will do is it will try to identify where is this packet going, where is this packet destined to, and then it actually identifies where it can actually put this packet so that it reaches its destination. So let's see how the router does that. Now, at this stage, once the packet gets, what it does is it does the concept called decapsulation. How does it decapsulate? It strips off the physical and data link layer. So when the packet is actually reaching the router 1, it will look like this. The physical layer will be having the encapsulated Ethernet. And remember, there are two major fields in the Ethernet header. One was the PC's MAC address, and another was interface 1's MAC address. Now, what it does is it decapsulate, or router strips off the physical and Ethernet headers, and then try to see what is there in the IP. So once it decapsulate at the router, it will look like this. It will be able to see what is the IP address, and inside the IP header it will check what is the destination IP address. Once it checks the destination IP address, it understands through the process called routing. Again, we will go deeper into that in the upcoming sessions, but we will see that the router 1 is able to understand that this packet has to be sent on to interface 2 so that it reaches the router 2 and it reaches the web server. Now, what happens is it has stripped off, remember, it has stripped off the physical layer and it has stripped off the data link layer. Now, what it does is, again, the data link layer is responsible for sending this packet in this particular link, which means for the packet to send in a link, you need to create an Ethernet packet because it has already stripped out the Ethernet packet now. So the router 1 will recreate the data link layer. It will recreate the Ethernet header, and what will have in that, when it creates, it will have the MAC address. It will have the MAC address of the interface 2 of the router 1, because this is the source. Now the packet is getting sent from the router 1 to router 2, so it will have the source MAC as the interface 2 MAC address, and for the destination MAC it will have the interface 1's MAC address. So again, once you create the header, recreate the data link layer, it will look like this. It will have the Ethernet header, which is having the source MAC of int2 MAC address of router 1, destination MAC as int1 MAC address of int1 of router 2, and it will encapsulate IP and TCP, and it will send it across to router 2. Now it sends the packet to the router 2, and what does router 2 do? Router 2 does the same thing. It strips off the Ethernet layer, because now it is not more relevant for the router 2 to have that Ethernet MAC. So it strips off, it again decapsulates, and then it checks where is the IP address. So it finds that the IP address is actually its web server, and it knows that it has to send to the interface 2 so that the packet reaches the web server. And finally, now the packets reaches the web server. Now what will the web server do? It will do the entire decapsulation. What that means is, now the web server gets the physical the ones and zeros, and inside that what is there is the Ethernet header. And what does Ethernet header has? Ethernet header has the source MAC address of int2, because when the router 2 sends the packet from router to the server 1, it will be using the source MAC as interface 2 of router 2's MAC and the MAC address of this interface of the web server. So now it has that. Now the web server, what is the intent of the web server? It finds that the destination is he himself, and now it strips off everything. It strips off physical, it strips off the IP address, it strips off the TCP, because all the thing that it is interested is to see what is there in the HTTP. So now finally what it gets is the HTTP request, or whatever data in HTTP that was generated by this PC. And then, since the web server is actually running the web service, it will be able to consume this request from the PC, because again, since it is actually running web server, it is running HTTP on port 80. So it is able to now read the data of whatever the PC has been sending it to. Now, once it gets the data, it will be able to respond it back as well. Now, this is a very high level information of what and how the encapsulation and decapsulation happens through a network, with a very, very, very simple example. There are a lot of other processes also happening, which includes DNS lookup, which includes ARP request, which also includes many other HTTP related stuff. How do you, again, this is TCP, that means there is a state maintained by the router and all those stuff. Those things, again, we will go deeper and deeper and deeper, but understand at the high level how encapsulation and decapsulation is very, very important for the data to be transferred in the network. Hope this is helpful. See you guys again. Thank you.